Geometry. These are the notes for lessons 1, 2, and 3 out of the workbooks we'll be getting this week. You're going to need a compass for today's lesson. That's your tool that's going to help us draw our circles. You're also going to need a straight edge. It could be a ruler, a protractor, your ID card, the edge of your binder. It really doesn't matter. They're just going to be short little segments we're going to be joining. And then finally, you're going to need a pen or pencil. You might find it helpful to have multiple colors for our lesson today. So once you've rounded up everything you need to get started, the first thing we're going to do is draw a circle on our page. So we're going to put a point P. That's going to be the center of our circle. So put point P on your page, label it with a capital P. And in this case, set your compass to a radius that is easy for you to work with. So usually not too small and not too large. Mine's about 1 inch long. And I'm going to put my center pointer on P. And my pencil then will be on the outside. And I'm going to hold down my compass such that it stays stuck on P as I move this circle around and create my circle around P. So for some kids, this takes a little practice. You might pause the video, draw a few circles, and then come back to the video. So I can name this circle. We name circles using the word circle and the capital letter that is the center point, the center of my circle. So this is called circle P, or you'll notice in my notes for a shortcut, I'll draw a circle with a center, and then I will put the capital letter that is the center behind it. Both of those would mean circle P. If I saw this in my notes, I would be saying circle P when I read it. So let's put a few other things on here. Let's put points A, B, and C around my circle. Put point A towards the top of your circle, point B somewhere in the center of your circle, and point C towards the bottom of your circle. These are points on my circle. Let's grab our straight edge and let's join our center point P to each of these three. So I'm going to draw with my straight edge from P to A, from P to B, and finally P to C. I have just drawn 3 radii. So let's put some vocabulary on our paper. AP, for instance, or PA, because order doesn't matter, is a radius. So if I'm talking about just one radius, I would use the word radius. However, if I want to talk about all 3 of these, so I want to talk about AP, BP, and CP, they are radii. The plural for more than one radius is radii. These all go from the center to the edge of my circle. You might also remember a diameter from a previous math class. Let's take our straight edge and let's draw all the way through my circle. Label the 2 places where it intersects your circle as N and M. Leave some space over here on the right below your circle. NM, and you can write MN if you'd like, is a diameter. A diameter is equal to 2 radii. You can see that NM is equal to NP plus, that would be this radius, plus PM. Again, the order doesn't matter. So a diameter is twice the length of a radius. So I could also say that NM is equal to 2, and I can use the name of either radius. So it's twice the length. NP is halfway across my circle, and NM is all the way across my circle. Let's go back over talking about our radii one more time. Our radii are all the same length. They are all congruent. So another vocabulary word is to be congruent, or this means same size, same shape. In this case, I'm talking about them being the same length. So we could say, and this is important here, you're going to use this reasoning in some of your homework problems. we could say that AP and BP, so go find those two. AP was one of my radii, and BP is another one. They are, you could say, the same length, the same size. I'm going to use the word congruent. They are congruent because, and I use BC for because, they are radii of the same circle. So you'll have a few practice problems where it'll ask you about two segments being congruent or being the same length or being the same size. One of those reasons that you might give is that they are radii of the same circle. That means that they would be the same length. They would be the same size. Every radius of circle P is exactly the same size. So let's take a look at another drawing. In this case, we're going to draw two circles. So let's start by putting, again, a point P on my page. And let's draw a circle using my compass with point P as my center. So point P is my center, and I'm going to draw my circle. And now I'd like to draw a second circle. So we need a second center. On circle P, I'd like you guys to find another spot and mark it on circle P, and let's call it Q. In this case, I'd like you to draw in circle Q. We're going to put our pointer this time on Q, and my pencil will be on P. You want to make sure if your compass has changed sizes, like if it's easy to move it, you want to make sure that your radius is exactly the same as it was when you drew P. So my pointer's on Q, my pencil's on P. And I'm going to draw a second circle. This circle has the exact same radius as circle P. They should be exactly the same size. So in this case, circle P and circle Q are the same size, or you could say that they are congruent, if you want to use that word, are the same size. This is because when I drew them, my compass was set to the same radius. So let's mark a few points that these two have in common. The first point I like to mark is where they intersect at the top. Can you please call that point A? I'd also like to mark where they intersect at the bottom. Can we please call that point B? So I want to mark another point on circle P. Let's call that point C. At this time, I want to join point P to A, B, and C. So not Q, just P. So let's stay in circle P. We're going to join P to A, P to B, and P to C. Those are all radii of circle P. So I know that PC, PA, and PB, put a single tick mark in each of them. I know that they're all the same size. I know they're all congruent. So you can see it right above. I'm going to rewrite this again. It's an important topic from here. I know that PC, PA, and PB are congruent because they are radii of the same circle, or in this case specifically, circle P. So you could write either the radii of the same circle, or you can say what circle it is, and in this case it's circle P. So now I'm going to get a different color. I'd also like to connect, let's connect A to Q, let's connect B to Q, and let's also connect P to Q, which I could have done before if I had wanted to. Here are three more radii, and actually all three of these pink lines are the exact same length as my green ones, because my two circles, P and Q, are the same size. So I know that, let's write all three of my circle P radii, PC, PA, PB, and now let's write my three pink radii, so AQ, PQ, and QB. So those are the three that I just drew in. I know that these are congruent. If you don't want to write the word congruent, you could write same size, because, now be careful here, this is a different reason and you'll need to be able to use this in your practice. They are radii, now careful here, of two congruent circles. Or some students like to write two circles that are the same size. Notice that this is different wording than what we wrote up above. So if your diagram and the lengths you're talking about are in two different circles, for example, AP is in circle P, but AQ is in circle Q, the reason that this green line and this pink line are congruent is because they are radii of two congruent circles. If you're talking about radii in the same circle, for example, PC and PA, then they are radii of the same circle, or in this case, circle P. You're going to use these two highlighted yellow statements as reasons in some of your homework practice. Before we leave this sketch, I want to point out a couple other things. This is about triangles. Hopefully I'm just reminding you of something you already knew, but if you could shade in the triangle on top, this is an equilateral triangle. Triangle, it's a triangle shape. Let's name it PAQ. PAQ is an equilateral. An equilateral, it's one word, equilateral triangle. An equilateral triangle has three equal sides. Literally, the word is equal sides. So I believe one practice problem will ask you about equilateral triangles. So I wanted to remind you what an equilateral triangle was. And in this case, this PAQ is an equilateral triangle because it's made up of three radii, which are exactly the same length. Also, you have a homework problem that talks about isosceles. An isosceles triangle has two equal sides. So I just wanted to remind you of those definitions that you've probably seen in math classes before our class. So the notes I've done on this page is lesson 1, and it actually went into lesson 2. So if out to the side, if you'd write lesson 2, this diagram and what I discussed is in both lessons 1 and lesson 2.